Okay, so let's kind of go over these, right? And this is why, not always, but oftentimes, there's either like a love or hate relationship with optics. Like you either think, this is cool, I like this, or this is a fate worse than death, okay?
We're way beyond that.
We're way beyond death, okay. All right.
You know which camp codes?
Now, so, let me give you an example of what I don't want, okay? This is what I don't want. So if you look like, for example, on number 1, right? So here's your center line, that's what we're gonna call your principal ray axis, okay? And then here's your lens, it doesn't have to be anything really to scale. Now, this is what would drive me crazy. Okay, if you want to set me off into a fit of rage, this is what you do.
Go and take notes.
Oh, he doesn't have to. And that's all I got. Okay? What does that convey to me? It conveys to me that you can draw pretty lines and a carrot. Okay? That's all that conveys to me. I don't know what the scale is. Okay? I don't know what the scale is. I don't know what the object is. I don't know what the image is. I don't know where your focal points are. Okay? This would set me into a fit of rage. Okay? It's bad. It's bad. Now, this, and again, it's just funny how you get used to it. I always draw left to right. Okay? That's what I do. That's for forever. That's how I learned to draw them. I always start on the left, and I might work my way to the right. Okay? You don't have to. There isn't a set rule. You could put the carrot over here and then draw the object over there. You can do that. I don't recommend it. I'll be irritated. But it isn't like a violation of the laws of optics. Okay? I'll just become frustrated. Got a dice roll you want to roll. So, on the focal points, okay, just don't put like a tiny little F hidden within there and go, oh, Burkamp will know what that is. No, Burkamp won't know what that is.
You need a magnifying glass, you're getting a 0.
So, again, here's your objective. When you look at your diagrams, do not look at them through the young eyes of an 18-year-old high school student who's just trying to get done. View them through the eyes of a 58-year-old grumpy physics teacher, 11 o'clock at night, who's going to be grading your paper. Okay? And it's like, will Burkamp be happy or will Burkamp be, ugh? Okay? If at all you think Burkamp's going to get cringy, probably not good. And if you're not sure if I'm going to get cringy, probably ask someone beside you, because you all have had me for like about 6 or 7 months. So if you're not sure, it's like, you think Burkamp's going to get cringy? And they look at it and they kind of go, that's bad, okay? I'm just telling you. So use your people around you to see if I'll get cringy with them. Okay, so let me give you some other guidelines. So if you look at number 3, so you have a concave cosmetic mirror has a focal length of 40 centimeters. The brush is placed 20 centimeters in front of the mirror. So you have a concave mirror. So what's that going to look like? This?
Yeah.
You know what I mean?
Like so. So
It's concave.
you have a focal length of 40. So, and again, show me what the scale is. Okay? Do not randomly put marks and go, Burkamp will know the scale. No, Burkamp won't know the scale. So maybe you're gonna let 1 centimeter equal 5 centimeters, okay? Whatever that is, show me the scale. So you're gonna come out here and go, okay, here's my focal length, and then here is the brush, and that's at 20 centimeters, okay?
Just in case.
So here's, personally, this is what I do anytime I have a mirror optics diagram. I'm gonna do, the first thing that I'm gonna do is that I'm gonna draw a line, and this is why I always like to make this like an even height, like 1 centimeter, 2 centimeters, something like that. Because that way, when I flip it over, then it's a nice even number, okay? So like when I did mine, I made that at 1 centimeter. You don't have to indicate the scale on, these two scales can be different. Like your horizontal scale could be different than your vertical scale, okay? So here's the story. So I always come in here and I draw this line to that center. And then I come down here where that's going to be symmetrical. And then I draw that second line. And then it's going to go out like this. So on this one, on number 3, here's what I know. Here's my 2 options. Either it's going to be an inverted image somewhere over here, or it's going to be an upright image over there. These are the only 2 locations where that brush can appear. Either down here or up there. It's either going to be inverted or it's going to be upright. Now, so with this one on number 3, okay, here's what you should see on number 3. Because you're inside that focal length, that brush should be somewhere out here, okay? So what's going to happen is that you're going to produce a real or virtual image.
Real image.
I heard both.
Virtual.
Isn't that such
Virtual, because it's going to be on the other side of the mirror, okay? Which means that I can't project that onto a screen, okay? So it's going to be somewhere out there. What's your magnification going to be? More than 1 or less than 1? More than 1. That's the whole point of a cosmetic mirror. You want things to look big. And you don't want them to be inverted. It's like, what happened to your lipstick? Oh, the mirror was upside down. I was just struggling. Okay?
Just got to feel like right here.
Yeah, it's like weird. Got lipstick on my forehead, and my mascara is down here on my chin. Weird. Okay. Now, so when you get to question number 5, okay? So on question number 5, if you compare 4 and 5, on 4 and 5, they're both concave mirrors, but here's the difference. On number 5, the object is outside the focal length. On 3, the object is inside the focal length, okay? So here's one of the things that you need to begin to squirrel away. Only concave mirrors can produce 2 different types of images, okay? Inverted, upright, virtual, real, okay? And you got to keep those straight. Now, when you get to number 5, so has anybody ever looked in the rear view mirror, and a lot of cars will have a little warning at the bottom? Anybody remember what that says? Objects in mirrors are close as they appear. Here's the reason why. These are going to be, all of those side view mirrors are going to be convex mirrors, okay? The reason that they're convex mirrors is a couple of reasons. One is that you don't want that big semi, if it's far away, appearing upright, and then all of a sudden it gets close, and then it gets blurry, and then it flips over, and now the semi appears upside down. okay, that would be bad, all right? You don't want, depending upon where the object is in your rear view mirror, is it upright or inverted? I don't know, kind of weird, okay? So that's one of the main reasons you don't use concave mirrors on your side view mirror. So these are all convex mirrors, okay? Now, the beauty of convex mirrors is that what's the only type of image it will produce? Inverted or upright?
Upright.
Upright. Convex mirrors only produce upright images. And they always have a magnification less than 1. Okay? So if you look on what's happening on number 5. So here's Billy on his bicycle. Here's the mirror. So again, what I always do is draw those symmetrical axes and then have that come back like this. Okay? Always start with that one. Again, if it's a dashed line, it's in the opposite direction of the ray. If it's a solid line, it's in the same direction. So you got that one, then you can send this one in parallel with it. It's going to try and go through that focal length on the other side. Boom, there's your bicycles. Okay? So that's roughly what that should look like on number 5. It's a crude diagram, but that's kind of what you're going to, this is what number 5 should look like. Again, label, object, image, focal lengths, all that good stuff. Now, here's the reason why they have that warning. Because of the fact that it's a convex mirror, your magnification is going to be less than 1. So, here's the reason for the warning. So you look in the mirror and you see this tiny little bicyclist or a semi-truck that looks really small. When you see images and they look small, what do you think?
Far away.
They're far away because of the fact that your magnification is less than 1. Okay? So the reason that is there is like you see this semi and it looks small and you think, oh, that semi's a long way away because it looks small. It looks small because it's a convex lens. Okay? And that's why that warning is there, because it looks small, so in your mind you think, oh, that's a long way away because it looks small. No, it's actually much closer, but it appears smaller because of the fact that it's bouncing off of a convex mirror. So let me give you some hints on these answers, okay? So I'm going to give you hints on the image distances. Okay? All right? On the image distances. And these are going to be in centimeters unless I tell you differently. So your answer to number 1, this is an ish, but it should be something around your age. Okay? On the front side, the image distance on number 1. This is an ish, but it should be somewhere around your age. Okay? Some closer, some further away.
Mitchell's 27.
Your answer to number 2, that image distance should be between 5 and 8 centimeters. Okay? On number 3, that image distance should be around 40. Cool with that. On number 4, that image distance should be around 30. And on number 5, in meters, that would be a horrible GPA. Gap Sean.
I was just making fun of scooters.
What?
So it was a horrible GPA. I was like, might as well be scooters.
Oh, that was harsh.
Well, that's hard.
I know. Sometimes truth hurts. Now, so, here's what I want, and again, you understand the spirit of how I wanted this done. On 1 through 5, I actually wanted you to measure it, okay? Now, when you get to the next set of calculations, now you're actually going to use the thin lens equation to get the values. Some of those answers should be negative. Okay? So on the actual calculations, you should have some negative values. Okay? Not all of them. It's just weird. I look up, Jacob's going and putting a blue dot on it.
It says both
Dash.
both dash.
Okay.
I don't know why these are here, they're just on my desk.
Okay. So let me give you some hints on the next set of fives, okay? So on the next set of fives, again, all you have to do is a sketch. It does not have to be to scale, but I do want labeled at a minimum the object and the image, okay? So on the last 1 through 5 on the back side, I at least want the object labeled and the image, okay? So let me give you some hints. On number 1, that image distance should be around 40, okay? On number 2, and again, some of these might be positive or negative. I'm just giving you the absolute value of them, okay? On number 2, that image distance, actually 2 and 3 should have an image distance of around 9 centimeters. Okay? So 2 and 3, both of them should have image distances around 9. Sydney, did you like that?
Me and Deacon are agreeing.
Huh?
Me and Deacon agree about stuff.
Okay. Your answer to number 4 should be around 40 in centimeters. And the lava lamp question, always a perennial favorite. That should be around, unfortunately, my age. And if so help me God, one of you says 90, I will flunk you.
Shut up!
Say it.
It's got bigger problems.
We went to
So make sure on the magnification that you indicate if that is positive or negative. Okay? So on 1 through 5 on the back side, I'm not worried about the front because you don't know necessarily the numbers in terms of sign. But on 1 through 5 on the back side, indicate if the magnification is positive or negative. Okay? You should only have two magnifications, excuse me. You should have 2 magnifications that are less than 1.
Does that mean negative or absolute?
I'm just telling you absolute value. The absolute value to the magnifications is less than 1. And they should be pretty close together on the ones that are less than 1. Okay? Any questions? Once? Twice?
Damn it, I'm falling asleep.
Focal length? So staple the diagrams to the back. Make sure that they are labeled, what they are, and you've labeled all the points. Okay?
Simply just don't understand. Neither do I. Hey, put it right here. I don't know what's going on.
As long as I'm more worried about the diagram.
This one is, you're so
Oh,
It's a complex figure, it's not fun. I was trying to get
thank you.
Problem is you're trying to you're starting off small.
I don't want
And then you're trying to get something small.
negative 5 or so.
over
Like
there.
on the first
I just
one.
do
So if
exactly
you
how
replace
it's
those
right.
bigger
Oh,
objects,
negative sign over so.
I was
Yes,
trying
they
to
do.
do this last.
because if you start
There's
with
only
small
one thing,
things,
guys.
like a small object, you can have a magnification less than 1, then you just shrink it down.
So just make options.
I would do that.
I thought you were talking about the scale of.
No,
I don't think I
no,
can
the
fit anything.
physical size of what you're drawing.
Okay, let's.
I have a pink one more.
10. No, just leave it flat. Here, have it. Where?
Okay, don't flip out, but I have much to hand out, but don't flip out.
Ah!
Your parents have to go to preschool with stage.
Like, first grade? Yeah, first grade. Yeah, first grade.
So yesterday,
2 meters, 4 meters away. So let's see. If the mirror's here, then
Rex was being out of his closet in his pocket.
this here.
Yeah, they were. I was
Why would you do this to us?
It's like, how am I supposed to respond to that?
God damn it.
I just think three spots were earlier. Also, if they were, if I use them as a.
What did you keep in your knee? What do you mean from?
I don't actually know where I got those.
What did you have in your bag that would
I'm gonna add a part to it and just start moving the lights.
We established that I was incredibly busy. I didn't have a single instrument to actually do it. Because on one hand, it means that we get less homework, but on the other, it means that we'll have homework.
I told you this, I told you this Monday.
I think it's state. I think it's relevant to state issue.
We're paying thousands of dollars to compete.
Sorry, I tried to put that on your lap because it was kind of progress stuff.
That'd be better than the
Like, what is when you stare down, it's like throwing down to the wall, it's like super bad.
I don't get bleaching it. I don't understand bleaching it. For that, I bet you it would be blonde. It would be a
I
blonde.
feel like high schoolers on certain
We're about to go to the meeting in the gym.
you gotta be short until it's like next week.
Yeah, like you can't.
Like, maybe kept his blonde way too long.
Wait, is these are different labs. Today and tomorrow? Today and tomorrow? Like one today, one tomorrow?
It's just the same.
Okay, so let me explain the labs that I just handed out. So, it's rare that it happens, but I've got to be gone. There's two things that are going to be unique between today and Friday. One is that I'm going to be gone tomorrow, okay? Which I hate with all my passion, but I've got to go down to Winfield, long story.
Does it? Does
So-
it mean no hope? Sorry.
Okay, so that's one thing that makes it unique is that I'm gonna be gone tomorrow. So basically, I left a note from the sub is like, hey, kids walk in, they just start working on the labs, okay? So, I'm gonna introduce both labs to Dave, which is gonna take a lot of time. Then basically, you're gonna have tomorrow and Friday. So Friday is like a catch-all work day. So I have never, to give you some idea of kind of how much time this is going to take for the diagrams and everything else, I have never once given you a work day, okay? Friday is going to be a work day.
No. No.
Would you prefer that I just start lecturing in the new unit?
No. No.
I have never in my life heard someone complain about me giving you a day to work.
No, it's not.
Maybe he
It's not.
shouldn't
It's
get
not
one.
about the giving us the day of work. It's the work.
It's the fact that you have that much to do.
Yeah. It's
But the
fact
good
that
news
you
is, if you
know.
play your cards right, you don't have homework. If you can get this done in class.
I'll have homework.
Huh?
You've had us for 6 months, do you think we're gonna get our stuff done here?
I'm hopeful.
Cohen, that's just you.
I'm hopeful.
Danny, we're not getting anything done
Okay,
either
wait,
in
wait,
our
wait.
group.
Get it done in class on Friday.
Huh?
He can get it in class done on Friday.
You're gonna have the rest of the day, all of tomorrow and Friday.
I won't have Friday.
So no homework the next 2 days?
Yeah. Literally, all you've got are those labs which are gonna be due on Monday. That's it.
Wait, post lab?
Huh?
I'm not leaving.
We have to do it post lab.
What post lab? Those are the
You're not gonna say
labs.
post lab?
The post lab,
Okay, anyway, so quit your whining. All right, so grab both labs and let's go to the back and I'll show you how it's going to be. Just leave the camera there because I gotta make it dark.